The research vessel Artemis sets sail into the stormy Pacific, its crew preparing for a historic dive into the Mariana Trench. Equipped with cutting-edge submersibles and sensors, they aim to explore depths exceeding 8,000 meters. The ship's deck buzzes with activity as engineers finalize pressure-resistant gear. Scientists discuss extremophile life forms that defy conventional biology. This mission could redefine our understanding of life under crushing pressure, where every square inch withstands the weight of 3 SUVs. The submersible Artemis plunges into the abyss, its titanium hull groaning under mounting pressure. At 1,000 meters, sunlight vanishes, replaced by bioluminescent jellyfish flickering like stars. Pressure gauges spike to 100 atmospheres, equivalent to an elephant standing on a postage stamp. The team observes the mesopelagic zone, where creatures evolve transparent skin to avoid predators. By 4,000 meters, the temperature drops to 2 degrees Celsius, and the sub's LED beams reveal ancient, drifting marine snow, organic debris sustaining deep-sea life. At 6,000 meters, disaster strikes. A hydraulic failure sends Artemis spiraling toward the trench floor. Alarms blare as the crew deploys emergency ballasts. The hull creaks under 600 atmospheres, a pressure that would crush a nuclear submarine. Through the chaos, sonar detects a thermal vent field ahead. These vents, reaching 400 degrees Celsius, host extremophiles with proteins stabilized by piezolites, molecules that prevent cellular collapse under pressure. The team realizes they've stumbled upon a biological oasis. Stabilized near the vents, Artemis captures never-before-seen life forms. Heat-resistant Rimicaris shrimp farm symbiotic bacteria on their gills, surviving in 80-degree C water. Microbial mats form living tapestries, their cells reinforced with branched hydrocarbons to resist pressure. The team identifies Chrysomalon squamiferum, a scaly foot snail with an iron sulfide shell, inspiring future armor materials. These organisms thrive by altering lipid membranes to remain flexible under extreme stress, a breakthrough for biomedical engineering. Beyond the vents, sonar reveals a colossal archway covered in bioluminescent coral. Dubbed Titan's Gate, the structure stands 30 meters tall, its surface etched with patterns resembling ancient runes. Pressure-resistant coral polyps secrete aragonite skeletons, a material 10 times stronger at this depth due to dissolved carbonates. As Artemis approaches, movement sensors detect rhythmic vibrations, hinting at something massive lurking beyond. The crew debates whether this is a geological formation or something engineered. The source of the movement emerges, a herd of whale-sized invertebrates, their gelatinous bodies exuding mineral-rich mucus. Dubbed the artists, these creatures sculpt towering spires by depositing layers of silica and calcium carbonate. Their cells contain piezophilic enzymes that function optimally under 800 atmospheres. The team observes one individual painting a spire with bioluminescent mucus, possibly to attract mates or communicate. This behavior mirrors human artistry, challenging notions of intelligence in extremophiles. The artists respond to Artemis with synchronized light pulses. Scientists theorize this is a complex language, perhaps sharing vent locations or danger alerts. Holographic analysis shows patterns matching fractal geometry, efficient for high-pressure sound wave transmission. The crew attempts dialogue by flashing the sub's LEDs. Remarkably, one creature alters its bioluminescence to mimic the sub's pattern, a first recorded interspecies communication at Hoddle depths. This discovery could revolutionize deep-sea exploration protocols. Without warning, a 6.7 magnitude tremor rocks the trench. Mineral spires collapse as sediment clouds engulf Artemis. The sub's thrusters struggle against debris. A single rupture could implode the hull. The artists scatter, their bioluminescence flashing urgently. Sensors detect a methane plume rising from the seabed, a byproduct of tectonic activity. The crew must ascend immediately, but the path is blocked by fallen spires. Time is running out. At these depths, rescue is impossible. As hope fades, an artist rams into the debris, clearing a narrow path. Its body tears against jagged silica, leaking glowing hemolymph, a sacrifice observed in no other species. The crew ascends, capturing final footage of the creature's bioluminescence dimming. Later analysis reveals its mucus contained barophilic proteins that stabilize human cells under pressure, offering clues for medical cryopreservation. This act of altruism rewrites textbooks on deep-sea ethology. Back on the surface, the team reviews holographic data that rewrites marine biology. The artist's mineral sculptures suggest a civilization older than humanity, while their proteins inspire new pressure-resistant materials. Yet 95% of the trench remains unexplored. As dawn breaks, the crew silently watches the ocean, knowing that below the artists continue their eternal work, untouched by the world above. The final frame lingers on the waves, a reminder that Earth's greatest mysteries are still hidden in the deep.